what's that picture going to look like? Here's Juliet up here in the window. And the window is 23 feet above the ground. And down here's Romeo. And he's looking up at Juliet. And his angle of elevation is 49. That goes here, right? What if it had been Juliet's angle of depression? Same place. They're congruent. How far apart are they? Where's the x go? What am I looking for? The hypotenuse. That's how far apart they are. So now I'm going to write an equation, and I'm going to use either sine, cosine, or tangent. And which one will I use? I heard somebody say cosine, and I heard somebody say tangent, and they're both wrong! The one we want is sine. Kids, with regard to this angle, which side is this? Opposite. Which side is this? Hypotenuse. So, katoa. So sine 49 equals 23 over x. So, katoa. So let's multiply by x and divide. So making sure your calculator is set in degrees because that's a degree measure. Oops, we're going to type in 23 divided by sine 49, 30.48. Is that what you got? We'll put a unit on it. So 30.48 feet. Anybody have a question about that one? All right, now we're going to fill in the blanks. All I know is that I got an angle out there whose cotangent is 4/3. Would you agree with that setup? That's what I know in this problem. So what am I going to do to be able to fill in all the rest of the blanks? I'll use the Pythagorean theorem and find my hypotenuse. So side squared plus side squared, 16 plus 9.
25.
Square root of 25 is 5. Now, usually that is not a number like 5. Usually it's something like root 17. But that doesn't change how we do the problem. Just makes it a little uglier. I'm going to go ahead and fill in the tangent. I could have done that right off the bat. If I know the cotangent, don't I automatically know the tangent? Now, what about the sine? What's the sine? 3 over 5, which means the cosecant is 5 over 3. Sine is reciprocal of cosecant. Cosine is reciprocal of secant. Cos do not go together. You have sine, cosecant. You have cosine, secant. No cos go together. All right, what's the cosine? 4/5. Adjacent over hypotenuse, which means the secant then is 5/4. Okay? When did we say this was? Tuesday? And someone will need to remind me I said this. I'm going to let you use your colored sheet, your pink sheet, on Tuesday. But that will be the last time. Okay? So if you do not have that stuff memorized, this weekend would be a good time to start getting it memorized. Because after Tuesday, it's not going to be used for assessments anymore. Okay? All right. 3 says find the exact value of the tangent of 4 pi over 3. Now, obviously you will have your calculator, but this says exact value. And gang, exact means no calculator. Because when you type something in on your calculator, it comes out as a decimal, and you round it off. That is not exact. So how do we find the tangent of 4 pi over 3 without our calculator? What are we probably going to do first? Ollie, are you getting ready to raise your hand there?
Divide the pi over 3.
Yeah, we're changing into degrees. So pi is 180, divided by 3 is 60, times 4 is 240. So this is the tangent of 240. So now I'll do what I've done in every problem. I'll draw a picture of it. So remember, you start here and go this way. So where will 240 be? Which quadrant am I going to put 240 in? Quadrant 3. Because 240 is between 180 and 270, right? Now this angle is 240. But the one I really care about is this purple one right here. Now just think, how big is that one? Use your common sense. Process it. How big is it? 60. It's absolutely 60 degrees. Because to get to 240, you have to go 60 past 180. You have to go to 180 and then 60 more. So that's a 60-degree angle. Which means the sides of the triangle across from the 60 is root 3. There are the sides of the triangle. Anything negative in there? Not the 2. The hypotenuse is always positive. The root 3 and 1 are both negative, aren't they? In quadrant 3, x and y are both negative. Horizontal and vertical are both negative in quadrant 3. So now I'm going to do the tangent. What's the tangent? This is your angle. Tangent is opposite over adjacent. So negative root 3 over negative 1, which is just root 3. All right, now we need our calculators because we're just going to be typing. All right, do you remember how to type this in? Tangent, 128. Second angle, degrees. 19, second angle, minutes. And then 13, alpha plus. So our answer is, gotta catch up. Negative 1.2653. Is that what you got? How many degrees? Is there a nod or some kind of either disagreement or affirmation? Okay. Cotangent 19. How do I type that in? No seconds. No seconds. How do we get a cotangent? 1 divided by tangent, 19. So that's 2.9042. Now, First of all, everybody get that? 2.9042? Now, there are times we use second tangent. But remember, that is only for situations like this. When you are finding the angle, that's when you second sine or cosine or tangent. Do I know the angle in this problem? Yes, 19. So 1 divided by tangent 19. No second, unless your job is to find that angle right there. Okay, change your calculator into radians. And then secant is 1 divided by cosine. 5 pi, use your pi button, divided by 17. I got 1.6594. Now, I don't know what you want to do, but remember, if you don't change anything, your calculator's in radians now. So when you turn it off, next time you turn it on, it's going to be in radians. If you want to change it back to degrees right now, you can certainly do that. It doesn't change itself. The only way it will change modes is if you physically change it. Okay, now I got to find a positive coterminal angle for 3 pi over 7. How do I find coterminal angles? Colin Broderick's doing exactly what y'all should be doing if you don't know. He's looking it up. I'll never forget when I was, I don't know, 3rd grade or something, I don't know, when I was little. And you're reading the Gettysburg Address, and how's it start out? 4 score.
7.
Yeah. Well, so here, I didn't know how many a score was. And I asked my teacher, what's a score? And she said, go look it up. And she said, Lisa, if you look it up, you'll remember it. If I tell you, you probably won't remember it. And you know what? She was right. I remember what that is. So when I tell you to go to your notes and look it up, it's to help you remember it. So what did you find out when you went and looked up how you find coterminal angles? We did them. Dave Jones, why are you sitting there staring at me? You add or subtract 360. Now, that is perfect if we're in degrees, because 360 is a degree revolution, right? So it's a perfect idea, but we're in radians. So what's a revolution in radians? 2 pi. Right, pi is 180, so 2 pi is 360. So to find a coterminal angle, we add or subtract a revolution. Obviously, adding will give me a positive number, and subtracting will give me a negative number. So I want, in this particular problem, I want a positive coterminal angle, so I'm going to add a revolution. If this had been 24 degrees, I would add 360. If it was a degree, I would add 360. It's a radian, so I'm adding 2 pi. What?
Why can't we change the radian to degree?
Because then you're going to have to change it back. The answer is going to be a radian measure, okay? So if you want to change that into a degree, add 360, and then change it back, you can, but no round-off error allowed, okay? I wouldn't do that. It takes too long. And it's dumb. We're just going to add 2 pi. That's so much faster. However, when you add 2 pi, obviously you have a fraction, so you're going to need to get a common denominator. and I'm gonna get 17 pi over 7. What would be different if the question said find a negative coterminal angle? I would subtract. So that would be 3 minus 14, so that would be negative 11 pi over 7. Finding coterminal angles is super simple. You either add or subtract revolutions. Okay?
Miss Lord,
Yep.
can I go to the restroom?
Is it an emergency?
I do really need to go.
All right, hurry up. Come right back because we have a lot going on today.
I know.
I'm trying to figure out where I stopped with you guys. Oh, we're ready for 4-4, aren't we? Yes. Oh, wonderful. 4-4 is all about graphing your functions. So, if you have your colored sheet with you, turn it over. And on the back of your colored sheet are the basic graphs, the unaltered BFF graphs for sine and cosine and tangent. But this section's only sines and cosines. Okay? Now, remember your sine shape from when we studied the BFFs? Remember that? That was on your flashcard? And remember we said you could tell them apart because the sine went through the origin? So see it going through the origin here? And the cosine doesn't. Remember the cosine starts up at the top? So these are the same pictures that you studied before, but now I have labels attached. So what you need to do right now is reproduce your sine graph in your notes, and right next to it is the cosine graph in your notes. Now we'll talk about what the A and PER stand for, but right now you're just reproducing the graphs from the back of your colored sheet. Notice that all the labels are exactly the same. We just started in different places. We're not doing tangent. Tangent is in the next section, 4-5. We're gonna modify our sines and cosines, get that under our belts, and then we'll move to the tangent because you can see these other shapes are a little bit different. Our main focus will be sine and cosine, but we will graph the other ones, but this will be our main focus. Certainly for today. Okay, now, I want you to look carefully at your sine curve. Well, and your cosine, they're basically the same picture. How high are the hills? 1. How low are the valleys? 1. That distance, the height of the hills and the depth of the valleys, is called amplitude. That's the height of the hills or the depth of the valleys. So the amplitude of your sine, A, that's what the A stands for in your notes, A is amplitude. The amplitude of both curves is 1. Okay? Now the PER stands for period. The period is how far the curve travels before it starts repeating. Now, it's a little bit hard to see on what I drew on your colored sheet, but here is what I drew, right? But did you notice it has little arrows on the end? That means that it does it again, and it does it again, and it does it again, and it just keeps going. So what I drew is 1 period. A hill and a valley is 1 period. Okay? So how far is it from the beginning to the end of that? What's that distance? 2 pi. Your period is 2 pi. Which, by the way, we just talked about that. What's significant about 2 pi? It's a revolution. So think about it. If I go all, if I'm graphing my angles, working with my angles, if I go all the way around, that's 2 pi, right? So if I go all the way around again, don't I get the same triangles? The period is 2 pi for sine and cosine. Okay, now C is where things start getting interesting. Okay, so let's see what happens with C. You are going to graph y equals 2 sine x. Anybody remember from back in the days when we were doing those triangles and trapezoids, those really weird things, and I said graph 2 f of x? Anybody remember what that 2 out in front does? Multiplies the y. So when I graph problem C, I am going to have exactly the same picture except instead of going up 1, it's going to go up 2. So there is a picture for problem C, 1C. Is the period still 2 pi? Yes, but now the amplitude is 2. The height of the waves is 2. Colin said it multiplies the y. Well, the amplitude of the original was 1. It went up 1 and down 1. This one is going to get times by 2, so its amplitude is 2. The number out in front, remember this, take a note, write it down, multiplies the amplitude. The original amplitude is always 1. Sines have an amplitude of 1. So whatever you put out in front is just going to be that number times 1. Same for cosines. So look at D. Now, first of all, would you agree that now I'm going up and down 3? But what else happened? Well, it's cosine. Yep, so the shape's going to be a little different. What else? There's a negative out in front. Who remembers what a negative out in front does? You know this. A negative turns us upside down. No, upside down. A negative out in front is an upside down. Okay? So, look at your cosine picture. Where does it start? A regular, normal cosine starts up here, right? But you've turned it upside down, so now it's going to start down here. Starts down here. And instead of coming down and making a valley, it's going to go up and make a hill. It's upside down. What is its amplitude? It's 3. And I know some of you might think, but wait, that's a negative. Amplitude is a height. Okay? So amplitude will never be negative. The number might be negative, and that turns it upside down. But the height will always be a positive number. Is the period still 2 pi? Yeah, we haven't done anything to change that. We can, but we haven't so far done anything to change that. All right, number 3, or E, I mean, E. Y equals 2 sine 2x. Well, I know what this 2 does. This 2 multiplies my amplitude. So when I draw this thing, I'm going to go up 2 and down 2. Okay. Izzy?
Is it shifted over right too?
Not this one. We're going to do shifting in F, letter F, because shifting happens when you add or subtract. That's when shifting happens. What happens when you put a multiplier on the x itself? Back in the day when we did this earlier, we had things like 3, f of 2x. This multiplied the height, or multiplied the y. What did this number do that was attached to the x? That changed this. And it changes it by dividing. This divides. Well, back then, it divided the width. Now we're going to say it divides the period. So wait a minute. I have a sine curve. Here's my sine curve. This is a sine problem. And it's supposed to end at 2 pi. That's where normal sines end. Where's this one going to end? 1 pi. Because this number divides the period, so the period is 2 pi over 2, which is pi. So this label now is pi. Well, isn't that going to change all the other labels? What's this one in the middle going to be? Half a pi. It's in the middle of 0 and pi, so it's going to be half. What's this one going to be right here? 1/4, very good. It's half of the half. And if that's 1/4 and 2/4, I guess this one will be 3/4. These things are always evenly spaced, you guys. So you can always check to see if you're right. Are they evenly spaced when you're all done? All right, the number out in front multiplies the amplitude, the height. The number on x divides the period width. Now the next problem, we have both of that happening, but then we also have something subtracted. So that's what Izzy was talking about. We're going to shift it. So what does that mean? No, I'm still going up 3 and down 3. And this is a sine picture. And the sine picture is supposed to start at the origin. But not this one, because what's happened to it? Izzy?
It's moving over to the right, it's
It's
gonna start
moving
at pi over 4.
over to the right, pi over 4. So my sine curve is now starting at pi over 4. When you add or subtract, that shifts you. If you're adding and subtracting inside the parentheses, it's sideways. If you had a number like +1 on the end, that would pick it up. So this one takes you sideways. The one out here, if you had one, takes you up and down. I hope that's vaguely familiar to you. We did all that back in like chapter 1. So I've got a sine curve that starts here. So I'm going to go ahead and draw in my sine curve. There it is. The shape doesn't change. You just picked it up and moved it. We always label where it crosses the axis, the high point and the low point. That's where your labels are every time. Where it crosses the high point and the low point all the time. Now you got to figure out where this ends, you guys. And it's very logical. So those of you that are still awake, you got this. Because the period is 2 pi divided by 2. Remember, the coefficient on x divides the period. And the period originally is always 2 pi. So 2 pi divided by this 2. Even though it's outside the parentheses, do you see that it's still the coefficient on x? So the period is pi. That means that from here to here is pi. This is not pi. Do you see why? Somebody explain to me why that's not pi. Izzy?
Because the whole revolution is 2 pi.
No. Over here, my period was pi, so I put pi here. What's different about this problem? Why can't I put pi there? Because I didn't start at 0, right? This distance is pi. So if I start at 1/4, don't let the pi's confuse you. You start at 1/4 pi, and you travel pi. This distance is pi. Where will I end up? 5 pi over 4, 1 1/4. 1 1/4, which is 5/4. So 5 pi over 4 is where I end up. Remember, period is a distance. It's not a label, it's a distance. So if you start at 1/4 and you travel 1, then you're going to end up at 1 1/4. This point right here, would you agree, is right in the middle of these? That makes it the midpoint. The midpoint is the average. Before you start freaking out, this is 1/4, this is 5/4. The average of 1 and 5 is 3. 1 plus 5 divided by 2. So this is just 3 pi over 4. Don't overthink it. Add them and divide by 2. All right, Kylie, did you get a pass yet?
Yeah, I did.
Great, show it to me and then you're ready to go. I'm still checking on Patrick's. I don't have one from him yet. Perfect. Be safe and smart. All right, any ideas? idea is what this one right here is gonna be. This is gonna be right in the middle of 1 and 3. What's right in the middle of 1 and 3? 2/4. And I'm okay if you don't reduce it in these graphs. There is so much to do in these graphs, so if you want to reduce that, great. But if you just leave it 2/4, I'm fine with that. What's right in the middle of 3 and 5? So this is 4/4. And again, if you want to make that pi, because that's what it is, that's fine. But if you leave it 4/4, I'm okay with that too. So our amplitude, let's write down the details here. Our amplitude of this curve was 3. Our period was pi, we figured that out. And our phase shift, sometimes also called horizontal shift, is pi over 4. This problem does not have a vertical shift. That happens when you put a plus or something on the end, okay? You don't have one. Yep.
So on like homework or tests, will we just have to memorize to do like, to write all these things?
No, I will ask you.
Okay.
I mean, I don't know what I did in the homework, but on the test, I will definitely have blanks for you to fill in.
Okay.
All right, let's look at the next one. Now, the next one is a cosine. Absolutely nothing that we have just talked about will be different except the shape. Everything we did will be the same except our shape. Boy, this looks scary, but you can do it. Amplitude is 1/5. Now, in reality, this is really squishy, but I want to spread it out so you can kind of see what's going on. So I'm just labeling this 1/5 and -1/5. Is that okay with everybody? That's fine. You can do the same thing. Otherwise, it just gets too cramped. Now, it's a cosine. So a cosine is supposed to start here and do this. That's what a cosine does. But this cosine is not starting here. Where is this one starting? Right here. It's been shifted. How's it been shifted? To the left, pi over 8. This one went right, pi over 4. Right? This one's going to go left, pi over 8. So this is a cosine curve. And it's starting over here at -pi over 8. That's its phase shift, or its horizontal shift. Now you need to label where it crosses, its low point, and its high point. Got it. What do we know about the period? In other words, from this hand to this hand would be the period. What is the period in this problem? How do we find the period? 2 pi over the coefficient on x, which is 1/2. So that's 2 pi divided by 1/2, which is 2 pi times 2 over 1. So my period is 4 pi. So this one got stretched, right? The period of the sine and cosine, always 2 pi. So this number is never going to change. So it's going to be 2 pi divided by whatever. Now, this is not 4 pi. The distance between my hands is 4 pi. which, by the way, 4 pi is 32/8. Would you agree with that? So I am moving 32/8, but I'm starting at -1/8. So where am I going to end? Here's my number line, here's 0. I'm starting at -1. I'm going to take 32 steps. Where am I going to end up? 31. So this label is 31 pi over 8. This is halfway in between -1 and 31. So average them. -1 plus 31 is 30, divided by 2 is 15. So this is 15/8 pi. This is in the middle, midpoint, of -1 and 15. So -1 plus 15, 14, divided by 2. So this is 7 pi over 8. Obviously, my scale is all whopper-jawed. Your labels matter. So don't worry about things not being, I mean, obviously, if that's -1, this can't be 7, right? But just look at the labels. The labels are what matter. This point is the midpoint of 15 and 31. 15 plus 31 is 46, and half of 46 is 23. Now remember when I said it was all going to be evenly spaced? Look, -1 to 7 is 8, 7 to 15 is 8, 15 to 23, and 23 to 31. So in the end, after you're done with all this arithmetic and all these fractions, just take a look at it and make sure they're all evenly spaced. They will be every time. Alrighty. Here we go. Guys, I know it's Friday. I know it's the last period of the day. I know you want to go play in the snow. But we are not going to stop. We have got to get this done. So let's tough it out. Here we go. All right, so step by step, we're back to a sine curve whose amplitude is 2. So I'm going to go ahead and just set that up right now. I also know that it's going to start at pi over 7 because my phase shift is positive pi over 7. It is a negative, I got the hiccups now. It is a negative sine curve. Negative sine curves do this. So I would suggest you put your phase shift on. It's right there in the equation. Can't miss it. And then sketch in your curve starting at that point. Now to do your labels, which are where we cross low and high, we're going to need to figure out our period. So, how do we do that again? How do we figure out our period? 2 pi divided by the coefficient, which is 1/3 this time. So that's gonna be 2 pi times 3, or 6 pi. So if there was a blank that said, what's the period, you'll say 6 pi. Which in this problem, I might want to think of as 42/7. And the distance from left hand to right hand is that. So what's this label going to be?
Which one?
This one.
47 plus.
It's going to be 1/7 plus 42/7, 43/7. Okay, one more time. If you're on a number line and you're at 1, and I tell you to take 42 steps, where are you going to end up? It is that easy, guys. Forget the fractions and the pies and all that. Use your common sense. You're going from 1 to 43. That's 42 steps. Now, what is right in the middle of 1 and 43? 1 plus 43 is 44, and half of 44 is 22. So this is 22 pi over 7. Now, what's the low point? Well, 1 plus 22 is 23, so that would be 23 pi over 7 if I added those together. Now I need to take half of that. Well, I can't take half of 23 evenly, so I'm just going to have to multiply by a half. So this label is actually going to be 23 pi over 14. Remember, when you find the midpoint, you add and divide by 2. When fractions are involved, you add and multiply by a half. Same thing's going to happen here. When I add these two together, I get 65. I can't take half of 65 evenly, so this is going to be 65/14. The arithmetic is sometimes ugly. But we are big kids, we can do it. All right, will you and your partner, I think there's one more. Yep, will you and your partner give this last graph a shot before we look at these next problems? Let's have our masks up, guys, so we're not breathing on each other. would you stop for just a second, look up here? Let's make sure we're all doing the right basic shape. Is this what you've got on your paper?
Yes.
Okay, keep going then, you're doing great. How many groups ended the curve at 17 pi over 6? One group, two groups. How did we get 17 pi over 6? We start at -1 and travel 18, so add 18, 6 I mean. Did you get 3 pi for your period? That's the key, you gotta have 3 pi for your period. It's 2 pi divided by 2/3, which is 2 pi times 3/2, which is 3 pi or 18/6. So if I start at -1/6 and travel 18/6, I'm at 17.
How do you go from 3 pi to 18 pi over 6?
I just got a common denominator with my starting point, 3/1, 18/6. You don't need to do that, it just makes it easier for me to find that point out there. -1 and 17 is 16, and half of 16 is 8, so I'm going to call this 8/6. I know it reduces, but don't. Just leave it be. -1 and 8, oh shoot, that's 7. Half of 7 I can't do evenly, so I'll have to multiply the fraction by a half, and that's going to be 7/12. So again, -1, 8, or -1/6 and 8/6 is 7/6. Half of 7/6 is 7/12. 8 and 17 is 25/6, and half of that is 25/12. Now, I may have interrupted you before you got done. Did anybody happen to get that? Any group happen to get that? Okay, if you didn't, do you understand what you did wrong? Okay, you obviously have homework, but there aren't that many problems in the homework. If you need more practice with this, go to the supplemental problems in Schoology. Pull up your book and do some sketching. I give you answers to those too, okay? All right.
You have homework for 4-4?
We have homework for 4-4, but it isn't due yet because we still have a lot more to go. But there is an assignment for 4-4.